So mean deviation and standard deviation for data that repeats itself frequently. First, what we do is we organize the data, right? So we did that previously. So I know that there are 5 ones, there are 3 twos, 2 threes, 3 fours, and 5 fives. So the mean here, we calculated, the mean is 3. So let's subtract 3 from all of them. Just like what you did previously. So difference is absolute value, as you know. 1 minus 3 is 2 there, 1 here, 0 there, 1 here, and 2 there. So let me just remind you what we did with regular data calculating the mean deviation. What we did was we put this is the mean, and we calculated the differences. If you guys remember, we calculated the differences, and then we added the differences, and we divided the differences, the total difference, with the number of data. So we're going to do exactly the same in different way. So we just did the subtraction here. Difference, we know the difference. Now we are going to add the differences. But remember that there are 5 ones. So there are 1, 2, 3, 4, 5 ones. If you subtract 3 from all of them, yes, it will be 2, 2, 2, 2, 2, which we have it here, but you have the difference 5 times. Therefore, when you find out the differences, hold on, where is the page? Okay, when you find out the differences, and yes, we need to add them, but you have to remember we have 5 twos, we have 3 ones, we have 2 of the zeros, we have 3 of the ones. So we have to do the multiplication here. So let's go ahead and do that. Now we are going to calculate the mean. So 2, how many twos we have? 5. 2 times 5 plus 1, how many ones we have? 3. 1 times 3 plus 0. Let's talk about 0. We have 2 of the zeros, but 0 times 2 is 0. It's nothing, so I don't even have to write down 0 here. So that just means nothing. So I'll just move on to the next one. One, we have 3 of them. 1 times 3 plus, and the last 2, we have 5 of them. So let's let's multiply 2 with 5. And I'm going to divide this with the total number of data, which is this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You can calculate that way, or simply add the frequencies. That will be 18 as well. So let's divide the total with 18. So 2 times 5 is 10. 1 times 3 is 3. 3. And 2 times 5 is also 10. So add them together, you will get 26. 26 divided by 18. Whatever this number is, that's the mean. I'm sorry, that's the mean. Whatever you get from here. Okay, let's do this once again. Whatever this number will come up with, 26 divided by 18. That's the mean deviation. So 1.44. So this is the mean deviation. How about standard deviation? It's almost the same, but first we need the squares, right? So this is 2, square that, 4, square this, 1, nothing, square that, 1, square this, 4. But you need to remember we have the square of number 4 5 times. 1, 3 times. So we have to do exactly the same what we just previously did. So let's give an example to that. Standard deviation. Let's go back. So let's do this. 4 times, let's use a different color. 4 times 5. 4 times 5 plus. The next number is 1. 1 times 3. 1 times 3 plus, then the 0, and I will ignore that. 0 times 2, I will ignore that. Let's move on to next number. Next difference, square difference. 1 times 3. 1 times 3 plus last 4 times, how many, what is the frequency? 5, 4 times 5. 4 times 5. So we will divide this with the number of data, which is, you add the frequencies, 18, or you simply count the number of data, which is 18. So let's divide this by 18, and 4 times 5 is 20, 1 times 3 is 3, still 3, still 20. So that is 20, 23, 46. 46 divided by 18. So let's get this number first. 46 divided by 18. That is 2.56. 2.56. But we are not done yet. This is the standard deviation. We squared all the differences. So we need to take the square root. Square root of that. That would be standard deviation. 2.56 square root 1.6. 1.6. That's the answer.